In this video, we'll talk about one more example of numerical measures of relative standing, and we are using the Z-score. This example is about a library book checkout. A city librarian claims that books have been checked out an average of 6 or more times in the last year. You suspect he has exaggerated the checkout rate or book usage, and that the mean number of checkouts per book per year is in fact less than 6. Using the computerized card catalog, you randomly select one book and find that it has been checked out 3 times in the last year. Assume that the standard deviation of the number of checkouts per book per year is approximately 1. So the important details given in that narrative are that the standard deviation is approximately 1, and that the number of checkouts for your book was 3 times. Now that is not the mean, that is an X value. The book has been checked out 3 times. And also, we are using population, so standard deviation is going to be mu, equal to 1 in this case. So if the mean number of checkouts per book per year really is 6, what is the Z-score corresponding to 3? So Z would be equal to X value minus mu, which is our mean of the population, divided by sigma. That's our standard deviation for population. So our X value is 3 checkouts from that random book we chose, minus the mean of 6, divided by standard deviation of 1. So 3 minus 6 would give us negative 3 divided by 1, and that gives us a Z-score of negative 3. A Z-score of negative 3 represents 3 standard deviations below the mean. And we consider negative 3 to be pretty far away from the mean. So for question B, or part B, considering the answer to part A, do you have reason to believe that the librarian's claim is incorrect? So even without any knowledge of the shape of the distribution, we recall that Chebyshev's rule states that at least 8 out of 9, or 88.89% of the measurements fall within 3 standard deviations of the mean. So that means 3 standard deviations above the mean or 3 standard deviations below the mean. Our Z-score is negative 3, so that's right on that boundary line. So we might be thinking that the librarian is exaggerating a bit and that the claim is incorrect. For part C, if you knew that the distribution of the number of checkouts was mound-shaped, would your answer to part B change? Well, the empirical rule states that almost none of the measurements should be above 3 standard deviations, that is, above a Z-score of 3 or below a Z-score of negative 3. Our Z-score was exactly negative 3, so it is right on the edge there. So again, we might claim that the librarian's claim is unlikely. There's one more question to go with this Z-score, and that is, if the standard deviation of the number of checkouts per book per year were 2 instead of 1, would your answer to parts B and C change? So what this represents is our standard deviation now is going to be substituted with 2. So our checkouts of the random book, remember, was 3 minus our mean of 6. That gives us negative 3 halves, which is negative 1.5 for the Z-score. So our Z-score is well within 3 standard deviations, and so this is not an unlikely occurrence. This is what we would expect more often than not. So this is not an unlikely occurrence, whether or not the data are mound-shaped. Therefore, we would not have any reason to doubt the librarian.